Welcome dear students. In this video I shall discuss about equation of first order but not of first degree. That means only first order derivative will appear in the equation. An equation of first order and the nth degree may be written as dy dx to the power n, and that's why this is not linear and its degree is n, plus f1 xy, if f1 is a function of xy, dy dx all to the power n minus 1 plus f2 xy dy dx all to the power n minus 2 and so on, f n minus 1 xy dy dx plus f n xy. That means f1, f2, fn minus 1 and fn, all are these functions are function of xy. Symbolically, if we put dy dx equals to p, then equation on becomes p to the power n plus f1 p to the power n minus 1 and so on. See, equation 2 can be considered as an algebraic equation in P. So equation 2 must have n roots. Let's say P1, P2, Pn be the roots of equation 2. And obviously P1, P2, Pn are functions of xy. So equation 2 can be written as p minus product of the factors p minus p1 times p minus p2 and so on, p minus pn equals 0. And this can be true only if one or more factors, this factor or this factor or this factor, vanishes, and hence any relation between x and y which makes a factor vanish will be a solution of equation 2 as well as the equation 1. So let's say phi 1 x y c1 be the solution primitive of first factor, phi 2 x y c2 be the primitive of second factor, and so on, phi n x y cn with the primitive of the last factor. So this should be a general solution of equation 1, but the problem is here c1, c2 we have n arbitrary constant. But our equation is of first order only, so we expect only one arbitrary constant. So if we put C1, C2, C3 up to Cn, which is equal to, let's say C, we put C in the place of C1, C2, Cn, then we will get the general solution. That means the general solution will be phi 1 x y c, phi 2 x y c, so 1 phi n x y c equals to 0, and obviously c is the arbitrary constant. Now let's try to solve example. First example is p square plus px plus py plus xy equals 0. Now see, if we take common from the first two factors, p will get p plus x, and from the second if we take y common, p plus x equals 0, or this can be written as p plus x, p plus y equals 0. and this happens only when p plus x equals 0 or p plus y equals 0. Now see, p is nothing but dy dx plus x equals 0, or we can write this as dy plus x dx equals 0. So solving will get y, or on integration we will get y x square by 2, and let's say this is c1 by 2. c1 is the arbitrary constant, so we'll get 2y plus x square minus c1 equals 0. And if we solve the another one, that is dy dx equals negative y, or dy upon y equals negative dx, or dx plus dy upon y equals 0, and integrating will get x plus log y minus, let's say, c2 equals 0. So therefore the general solution will be the first one, x square plus 2y minus c1. At the place of c1 we will put c times, the second one is y plus log x plus ln y log y minus c2. We will put c here, and that is equals to 0, and we must write that c is the arbitrary constant, arbitrary constant. Second example, x square p square plus xyp plus 6y square equals 0. See, this is quadratic equation in p, so we can solve easily, or we can write this as x square p square plus 3xyp. If we factor the middle term, 3xyp minus 2xyp minus 6y square equals 0, or take common xp, we'll get xp minus 3y, and take 2y common, xp plus plus 3y equals 0, or xp plus 3y times xp minus 2y equals 0. So from here xp plus 3y equals 0, or xp minus 2y equals 0. For the first one we'll get p, that is dy dx equals negative 3y by x, or dy upon y equals negative 3 dx upon x, or 3 dx upon x plus dy upon y equals 0. On integration we will get 3 ln x plus ln log y equals c1, or let's say log c1. So then we will get log x cube y equals log c1, or x cube y equal minus c1 equals 0. Okay, and another one is dy dx equals 2y upon x, or dy upon y, here 2 times dx upon x, or 2 dx upon x minus dy upon y equals 0. So 2 log x minus log y equals log c2. c2 is arbitrary constant. From here we will get log x square upon y equals log c2, or x square by y minus c2 equals 0. So therefore the general solution will be product of these two, with replacing the arbitrary constant by one arbitrary constant c, that is x cube y minus c times x square upon y minus c equals 0, and where c is arbitrary constant. Example 3, solve p square plus 2py cot x equals y square. Okay, see, this is again a quadratic equation in p, so we can solve for p. So write this as p square plus 2py cot x minus y square equals 0. Therefore p is negative these things 2y cot x plus minus root over square of this, so 4y square cot square x plus 4y square upon 2. So that means 2y cot x plus minus 2y root over 1 plus cot square x upon 2. So 2 get cancelled, so negative y cot x plus minus y, and root over 1 plus cot square x is cosec square x, so that means cosec x. Okay, so p is minus y cot x plus y cosec x, and another is p is negative y cot x negative y cosec x, or dy dx equals negative y cot x minus cosec x, or here dy dx equals negative y times cot x plus cosec x, or we can write this as dy upon y and negative cot x minus cosec x dx. So we'll get log y, here negative the integration of cot x is log of sin x, and integration of cosec x is negative log of cosec x minus cot x, because see, if we take the derivative of log of sin x. So d log of sin x, that will get 1 by sin x, and derivative of sin x is cos x, so we will have cot x. And on the another hand, derivative of log of cosec x minus cot x will get 1 by cosec x minus cot x, and the derivative of cosec x is cosec x cot x, and derivative of cot x is negative cosec square x. Cosec square x. See, if we take from the numerator cosec square x, cosec x will get cosec, this will get cosec x only. So from here, and we must put an let's say log c1, arbitrary constant c1, so we'll get ln y negative ln sin x upon cosec x minus cot x minus ln c1, or y sin x upon cosec x minus cot x c1 equals so we'll get y time sin x upon cosec x minus cot x equals c1, or y sin x upon cosec x minus cot x minus c1 equals 0. Let's name it 1, and from this equation what we will get, dy upon y, will get dy upon y plus cosec x plus cot x, cosec x plus cot x dx equals 0, or log y plus log cosec x minus cot x plus log sin x equals log c2, or y times sin x into cosec x minus cot x minus c2 equals 0. So product of these two, that therefore the general solution is y sin x by cosec x minus cot x minus c times y sin x times cosec x minus cot x minus c equals 0 is the general solution. C is the arbitrary constant, and this can be simplified further. Here are the questions for your self-test. Please take screenshot and try to solve these questions. If you get any complicacy, please do comment. Thank you.